Ever think about that future we were all promised? Like, okay, flying cars, maybe not so much yet, but like robots helping out with everyday stuff.
I know, right? Still feels like we're waiting for that big robotics revolution.
Well, this might be it. Things could be getting interesting really fast thanks to some big announcements from NVIDIA.
Definitely some exciting news coming out of their GTC conference. We've been digging into reports from the Cryptonomist, and it seems like they're not just improving existing robots, they're building the foundation for something entirely new.
Yeah, a whole new generation of humanoid robots. So today we're doing a deep dive into NVIDIA's Isaac GR00T N1 model and all the tech surrounding it.
Okay.
Our mission here is pretty straightforward. We want to understand what these innovations really mean and what the potential is for, creating robots that aren't just tools, but genuinely intelligent and adaptable. So for everyone listening, we'll make sure you get a clear picture of what's important without getting bogged down in the technical stuff.
Sounds like a plan.
Where should we start? What really caught your eye?
Well, NVIDIA isn't just focusing on building a better robot, they're creating a whole ecosystem. From the AI that powers it, to the simulation tools used to train it, even a new physics engine, all designed to make building these robots faster and easier. And at the core of it all is this Isaac GR00T N1 model.
All right, let's break down GR00TN1. It's been called a fully customizable, open-source base model for humanoid robots. What does that actually mean for someone who wants to build or maybe even just use these robots?
It's like having a super advanced starting point, a template, but with built-in intelligence and core capability.
Okay, interesting.
This lets other companies and researchers adapt it to their specific needs, rather than having to start from scratch.
So it's not just the hardware, it's the software and AI built in.
Exactly. And making it open source is huge. It encourages collaboration, lets people experiment and make progress faster, and the core capabilities they're talking about, advanced reasoning and generalized skills, those are what could let these robots go beyond simple tasks and become truly helpful in more situations.
Generalized skills, huh? That sounds like the dream for robotics, right? Not just doing one specific pre-programmed thing.
Exactly.
How does GR00TN1 achieve that ability to learn and apply skills more broadly?
Well, they're using a really interesting dual system architecture. It's actually based on how human thinking works. A fast, intuitive system for quick actions, they call that System 1, and then a slower, more deliberate system for complex planning, that's System 2.
So it's like our quick reflexes and our more thought-out decisions working together.
Exactly. And then, to bridge the gap between sensing the world and acting in it, GR00TN1 has a vision language model, or VLM.
I see.
This VLM is special because it can interpret information from the robot's cameras and sensors, but also understand instructions given in natural language.
So you could just tell it, like, clean up this table, and it would use its vision to understand what that means, figure out the objects and where they are, and then actually do it.
That's the idea. The VLM translates that instruction into the specific movements needed to carry out the task. And this is where the training data comes in. They've used a huge dataset of human demonstrations, basically showing the robot tons of examples of how we do things. But what's really groundbreaking is their use of synthetic data created with NVIDIA's Omniverse platform.
Synthetic data. That sounds like they're building a virtual world for the robot to learn in. How does that work?
You got it. It's simulated data. Instead of only using real-world examples, they can create endless scenarios in a virtual environment. The robot can learn much faster and in more situations.
That's pretty amazing.
It is, like a pilot using a flight simulator to practice without ever leaving the ground. The reports talk about GR00T N1 doing really complex stuff, like grabbing objects with one hand, switching them to the other, and even doing multi-step actions.
That's a big jump from the robots you usually see in factories, just stuck doing the same repetitive task.
Totally.
The possibilities for industries are massive. More flexible handling of materials, better packaging, even doing quality inspections.
Absolutely. And it's not just factories. They're talking about uses in our homes, too. Imagine robots that can actually help with chores, or support elderly people, or give more independence to people with disabilities. You can really see the potential in the official NVIDIA video.
Definitely worth checking out.
For sure.
Now, the reports also mention some early adopters, companies already working with GR00T N1. 1X technology seems to be one of the first.
Yeah, they've been using it to train their Neo Gamma robot to tidy up spaces.
Interesting.
And their CEO, Bernd Bernich, said that GR00T N1 lets them build more adaptable robots, ones that can learn new skills quickly with way less data.
That's pretty impressive. So instead of having to program every single movement, the robot can learn by watching and being exposed to these huge data sets.
Exactly. And 1X isn't alone. Companies like Agility Robotics and Boston Dynamics have early access too. It really shows how excited the industry is about this technology.
So it's more than just hype. This is real progress. But the advancements don't stop there. NVIDIA also announced this new physics engine, Newton. Why is having a special physics engine so important for building robots?
It might sound technical, but think about how robots interact with the world. They need to understand gravity, friction, how things move when you touch them.
Right.
A good physics engine makes the simulations more realistic, so the robot learns how to move safely and efficiently. What's really cool is that Newton was developed by NVIDIA, Google DeepMind, and Disney Research, all working together.
Disney Research. That's a surprising combination. What are they doing with a robotics physics engine?
Well, they're looking at how Newton can improve their entertainment robotics. They even showed off some Star Wars droids at the GTC keynote.
Wow.
Kyle Laughlin from Disney Imagineering R&D said this collaboration will let them make robots that are not just functional, but also more expressive and engaging. So it's not just about industry or home use. There's a potential for things like entertainment, even making robots seem more human.
So optimizing factories, creating immersive theme park experiences, the possibilities are huge.
Absolutely.
We've talked a lot about synthetic data. The reports really highlight this with the Isaac GR00T blueprint. Why is this approach to training data so revolutionary?
The biggest challenge with these robots is the sheer amount of data needed to train them. Getting enough real-world examples of humans doing all sorts of tasks is slow, expensive, and sometimes just impossible.
Right.
The Isaac GR00T blueprint solves this problem by creating huge amounts of synthetic motion data from a small set of real human demonstrations.
So you take a few examples of a human doing something, and this tool generates endless variations and scenarios for the robot to learn from.
Precisely. The reports say they generated 780,000 synthetic trajectories, which is like 6,500 hours of human data in just 11 hours. That's an insane speed increase.
That's unbelievable.
I know. And the results are there. GR00TN1 was 40% better when trained with this synthetic data in real-world data compared to just real-world data. It really shows how powerful this approach is.
So much faster development. That's amazing. But with all this advanced technology, how are they making it accessible to other developers and researchers who want to use GR00TN1?
Well, NVIDIA is really committed to creating a large community around this. They've put the GR00TN1 training data and a bunch of evaluation scenarios on sites like Hugging Face and GitHub, which are super popular with AI and robotics people. The Isaac GR00T blueprint is also available as an interactive demo on their website and as a download from GitHub.
That's great. It means more people can start experimenting and building on this technology.
Exactly. And for those who need more computing power, they also have the NVIDIA DGX Spark. It's a personal supercomputer built to handle these complex AI models without needing tons of equipment.
So to sum up, we have a super adaptable and intelligent robot base with GR00TN1, a sophisticated physics engine in Newton to make interactions with the real world more realistic, and this revolutionary way to create training data with the Isaac GR00T blueprint. It feels like all the pieces are in place for a major leap forward in humanoid robotics.
You nailed it. These developments, taken together, aim to make robots more independent, efficient, and adaptable, not just for specific tasks, but for a much wider range of things that could impact our daily lives.
It really feels like we're about to see AI merge with the physical world in ways we've only imagined before.
Absolutely. Imagine robots that can think, learn from real and simulated experiences, and interact with their environment in a realistic way. This has huge implications for everything, from manufacturing and logistics to healthcare and personal assistance.
It's mind-blowing.
It is.
So as we wrap up this deep dive, it leaves us with a big question. If we're really heading toward a future with these super capable robots working alongside us, what new possibilities will that open up?
Right.
And maybe even more important, what challenges might we face as a society? It's something worth thinking about.
Definitely.
Thanks for joining me for this fascinating look into the future of robotics. It's going to be an interesting ride.
Absolutely.
Until next time, keep exploring.
See you then.